All right, so the top graph is simply you giving me the equation. So tomorrow on our test, there will be absolute value graphs. They'll be very similar to the homework you just had that was due today. There will also be piecewise. The piecewise graphs are going to be two different types. One like this example, where you have to give me the equation, and one like the example below, where I give you the equation and a graph. So if you get one like this, then this is technically two kind of equations. You need to identify the breaking point. So what value of x do these two graphs break at? 1. So that means my x values are going to be less than 1, and my x values are going to be greater than 1. At some point, my x is equal to 1, and that's where the graph is closed. So is the closed circle going to be with the x values greater than 1, or the x values less than 1? So that means where x is greater than 1, maybe, we're going to include it. So it's going to be x greater than or equal to 1, or x values less than 1. What's nice about the x values less than 1 graph is that that graph goes through the y-axis. So therefore, I can easily see the y-intercept. So what y value does that graph cross the y-axis? So for x less than 1, my y-intercept is -2. What is the slope of that line? It's 1, right? Because from here to there, you go up 1 over 1, up 1 over 1, up 1 over 1. So my slope is 1. So the equation of that line is x minus 2 for x values less than 1. Now, x values greater than or equal to 1 is a little bit trickier because it doesn't go through the y-axis. So you got to first identify your slope. So from this point here to the next nice point, how many am I going up and over? Perfect. We go up 2 and over 1 to the next nice point where it hits at a corner. So you're looking for where it hits at a corner. Up 2 over 1. So that means my slope is 2 over 1, or simply 2x. Now's where you have a choice. You can take that slope and apply it backwards until you hit the graph of the line, or you can use point slope form and rewrite the equation of the line using a point on the graph and your slope. So again, you have two choices. You can take the graph, continue it backwards until you hit your y-intercept. So if I go down 2 and left 1, what's my y-intercept? -1. Or again, like I said, you could take your point. So we have the point 1, 2, 1, 2, 3. So we have the point 2, 3. And I know my slope is 2. So you could do y minus 3 equals 2, x minus 2. Distribute. And solve. Two choices, both are good. Questions, comments, concerns on writing the equation of a line for the piecewise? Okay, follow up. Now for tomorrow, you do not have to do it on these equations, but you do have to do it if there is a graph. So if you looked at the graph you created, like let's say you gave me this graph, I would anticipate that you could tell me domain and range. So what's the domain of that graph? What's the domain? All reals. It's not a trick, it's a true statement, right? This is x less than 1, this is x greater than or equal to 1. The breaking point x values match, therefore your domain is the range, as the y values. Y's are up and down. So my range has to do with the y's. This graph, the y is going. This one, my y's are going. All right. So do any y's live in here? So you got to mesh the two ideas together. This one is going to give me all the y values less than -1 and down. So that's y values less than -1. This one gives me all the y values from 1 and up. So y is less than -1 and y is greater than or equal to +1. If you don't like using the y's and you like doing the negatives and the infinity stuff, this would be -infinity to -1 bracket 1 to infinity. Both are fine. I like either. Don't care. But some people like one, some people like the other, so I put both. Good? Great. Grand. Glorious. Let's move down. Hopefully it all fits. All right. Where's my breaking point? -1. So if you like a table, what number are you writing twice? Maybe. All right, let's color coordinate. Purple is going to go with x values less than -1. So that means that that is my top equation. Because up top is where x's are less than -1. So in order to fill in that table, I'm going to plug values at -1 and less than -1 into that equation. What are some numbers less than -1?
-3. -3. I just swear sometimes it has like a mind of its own.
At -1, is that point on my graph going to be open or closed? Because it's less than but not equal to. All right, plug in your points. When x is -3, you get a minus, a minus, a minus, a minus turns to a. So at -3, you get 3 minus 3, which is?
0.
-2. So a minus becomes a +2. 2 minus 3 is?
-1.
And negative and -1 becomes 1. 1 minus 3 is?
-2.
So the point -1, -2 is open on my graph.
Watch it be all over the place.
I know. Like, what? Are you laughing at the full concentration on my face? That was so difficult.
I'm a little scared.
I know, it's not circular at all. There we go. All right. Bottom equation. Let's go with whatever reddish color that is. Oh.
You call that color skin color? Yeah. Thank you. Very hard. It's tough to say.
At -1 for the bottom equation. Is the point open or closed? Plugging -1 in, 2 times -1 is -2 plus 2.
0.
So at -1, we have the point -1, 0 filled in. And then my slope is positive 2. So it's going to go up 2 and over 1 from that point. You can also check by plugging 0 in. 2 times 0 is 0. 0 plus 2 is 2. 2 times 1 is 2. Plus 2 is 4. And you could go up 2 and over 1 again. Then you have your 3 dots on the graph. This is for x values as x gets bigger. So you connect your dots and put your arrow. What is the domain? What is the range?
Is there a 2?
Nope.
So y is greater than -2.
Yep. Because this is the lowest point and both graphs are going up. I expect perfection tomorrow.